May 2018 AS Applied Paper Question 8. Particle P moves along the x-axis. At time t seconds where t is greater than or equal to 0, the displacement x meters of p from the origin 0 is given by x equal to half t squared brackets t squared minus 2t add 1. Part A, find the times at which p is instantaneously at rest. So looking at this, we can expand the brackets and we get x is equal to t to the 4 over 2 minus t cubed plus t squared over 2. Now, times where it's instantaneously at rest is going to be where the velocity is 0. In order to get from the displacement to the velocity, we need to differentiate. So dx dt is going to be equal to v, which is going to be 4t cubed over 2 minus 3t squared add 2t over 2. So simplifying this, we get v is equal to 2t cubed minus 3t squared add t. If it's instantaneously at rest, we know that v is equal to 0, so we can factor the t out. We've got 2t squared minus 3t add 1 equals 0. We factorise what's in the brackets, and we end up with 2t minus 1 and t minus 1 there. So we have three values. One of t is equal to 0, one of t is equal to a half, and one of t is equal to 1 for the times at which it is instantaneously at rest. Now looking at part B, find the total distance travelled by p in the time interval between 0 and 2. So we know that we've got t equals 0, t equals a half, and t equals 1 where it's instantaneously at rest, and we also want to find where t is equal to 2. So if we look at the displacement at each of these times, so we sub t back into our equation for x, so we're subbing t back into our top equation here. When t is 0, we get a displacement of 0. When t is a half, we get a displacement of 1 over 32. When t is 1, we get a displacement of 0. And when t is 2, we get a displacement of 2. So what this tells us is that if we have a total displacement at the end of 2, when t is 0, we go along to a displacement of 1 over 32 from here to here. What then happens between a half and 1 is the displacement goes from 1 over 32 to 0, so we go back again. And then from 0 up to 2, we go all the way along there. So the total displacement is going to be 1 over 32 add 1 over 32 add 2. So this is going to be 33 over 16 as our total displacement. Now for part C, show that p will never move along the negative x-axis. So that means that our displacement will never ever end up being negative. So if we look at this, we can say x is equal to a half t squared brackets t squared minus 2t add 1. So a half t squared must be greater than or equal to 0 because t is squared. And looking at t squared minus 2t add 1, if we look at the discriminant b squared minus 4ac, we can say that minus 2 squared minus 4 lots of 1 is going to be 0. Therefore, what we know is that it has equal roots, and we know that t squared minus 2t add 1 must be greater than or equal to 0 at all times. It won't dip below that. And so therefore, if a half t squared is greater than or equal to 0, and t squared minus 2t add 1 is greater than or equal to 0, then we know that x must be greater than or equal to 0, and it will never go